today concept for your memory, we'll see this XT graph. Okay. So what is XT graph? Position time graph. Position time graph. What is it? What does it actually mean? It represents the position of a particle, okay, at various instants of time. Okay. Now first we are going to see position of a particle at rest. Okay. So how the graph should be? We are going to see how the graph should be. Position time graph of a particle at rest. XT graph. XT graph for a particle at rest. Let the position be along the y-axis. Suppose if you are taking coordinate axis, x and y axis, position, it is represented by letter x. Okay. So it is along the y-axis and time along the x-axis. Now, suppose if the particle is at rest, then what happens? Okay. Suppose if time t is equal to 0, you are viewing the particle is here now. Okay. It is at rest. Suppose if the time is running 5 seconds, 10 seconds, still the particle is at rest, at the same position. Okay. There is no change in position. Okay. The position remains unchanged. So now, if you join these points, then it will be a straight line which is parallel to the x-axis. Okay. This is nothing but it is XT graph for a particle at rest. Then we will see XT graph. Second one, XT graph for a particle with uniform velocity. Particle moving with uniform velocity. Okay. Particle moving with uniform velocity. Then what happens? Say here the same thing. So y-axis and x-axis. At y-axis x position, at x-axis t position. If the particle is moving away from the observer, suppose if the observer is here, if the particle is moving away from the observer, then what happens with uniform? Okay, it linearly varies like this. Okay, so this is nothing but uniform XT graph for a particle moving with uniform velocity. It may be like this, or it may be from the negative side, or it may be along this side, whatever it may be. If the particle is moving with a uniform velocity which is moving away from the observer, that is, it is nothing but it is positive side of the x-axis. Okay, so it is nothing but XT graph of a particle moving with uniform velocity. Okay. Then we will see XT graph. We will see third one, XT graph for a particle moving towards the observer, but in the negative direction. What is that? Particle moving with the same uniform velocity. But the case is consider this as y-axis and x-axis the same way. Position time graph. Then what happens? Suppose if the particle is moving towards the observer. Okay, observer is here. So the particle is moving towards the observer and it is in the negative direction. The slope is negative like this. Okay. This is nothing but the XT graph for a particle moving with uniform velocity, and also it moves in the negative direction which is towards the observer. It is nothing but it is an xt graph for a particle moving with uniform velocity which is away from the observer in the positive direction. Okay. Particle moving with uniform acceleration in the positive direction. Okay. Uniform acceleration. Particle moving with uniform acceleration. Okay. X, y axis, position of a particle, and the time axis. Now, the particle is moving with uniform acceleration which is away from the observer and in the positive direction. So, what the away from the observer and in a positive direction like this. Since what is the acceleration? Meter per second square times square axis. It is nothing but times square axis. If it is square, then it will be a curve, right? Then again another one. This is nothing but a particle moving with uniform acceleration. Okay. Again, it is nothing but it is in the negative direction like this. Away from the observer and it will be in the negative direction. Okay. Then we are now going to see the particle moving with uniform deceleration, retardation, deceleration. So it is totally opposite for this. Okay, like this. Okay, here it is x, y, time axis. Then what is the deceleration in the positive direction? Like this. Suppose if the curve bends like this, it is concavity. Now it is convexity. Okay. So here this is nothing. It is positive direction, and away from the observer, it is nothing but uniform deceleration, particle moving with uniform deceleration, which is in the negative direction likewise. Okay. So this is nothing but this whole the position time graph. Okay. This is very useful in order to find the instantaneous velocity and then instantaneous position, average velocities, everything. Okay. And the displacements of the particle also. And then it is more useful for your JEE main problems, problem solving.